Hello everyone, in this video I'll be explaining you the problem threshold moment, and this was asked in Codeforces round 1112 for rated for division 2. So let's read out the problem. There are n plus 2 positions numbered from 0 to n plus 1. Initially position I contains an element of weight wi. For every I greater than equals to 1 less than equals to n, while position 0 and n plus 1 are empty. Okay, you choose an integer k, then every element moves exactly once simultaneously. If weight of that ith element is less than k, the element at position I moves to the position left side, I minus 1. If weight of I is greater than k, then the element moves to the right side by one index, which is I plus 1. If weight equals to k, the entire movement process fails immediately. Okay, so an integer k is perfect if the movement does not fail. Okay, and upon completion every position from 1 to n contains exactly one element. So here the trick is every position. Okay, I had missed this, so in the contest I was not able to solve, but I was struggling for that. Determine whether a perfect integer k exists. Okay, we have to determine if integer k exists or not. If it exists, then we have to print yes or else no. So if you see the test cases, we have t number of test cases, and for every test case we have integer n denoting the size of the weight array, and in the next line we have n weights from w1 to wn. So yeah, this problem seems to be quite good. Let's go back to iPad and try to solve this. So we are solving the problem movement, threshold movement. If you see the problem here says we have given the array of length n, and their weights are w1, w2, w3 up to so on wn, and they are asking us to choose an integer k such that it's a valid integer. Okay, valid in a sense, if you choose integer k, so for all index I from 1 to n, if weight of that ith index is less than k, then you need to shift that index to the previous index, which is I minus 1. If the weight of index is greater than k, then you need to shift that weight to the I plus 1, that element to the I plus 1. And if weight is equals to k, then the moment that you are doing a shifting, it fails. So in order to be integer a valid one, the movement should not fail. Okay, so now the question comes, how do you solve this? If we see the test cases, n is 100, so in a brute force way we can do, so n is equals to 100, so brute force can be done, but the weight of it can go from 1 to 10 power n. So okay, how can we solve this is the question. So if we see some examples, let's say I'll take this example, fourth one. Here n is 4 and the weights are 9, 1, 7, 2. Okay, so and if you see the k range, they are not given, we have to choose it. So the thing is, since this n is very small, like 100, so we can do a brute force solution of this, and basically in the problem what they're saying is you can choose integer k, and k's range, if they let me see, case range they have not given, we can choose negative as well, there's not an issue. So yeah, k range can be integer minimum to the integer maximum, but since weight is from 1, why you will go up to integer minimum. You can go up to k0 till 10 power 9 plus 1. This is very important, you have to understand this in order to solve this. In a brute force, what we can do is we can choose k value from 0 up till 10 power 9 plus 1, and we can create a frequency vector, okay, wherein the frequency vector size will be n plus 2. So this is first index, this is second, this is third, this is fourth, this is fifth, and this is 0th. Since here the size is 4, so our elements belong to this one only, and in the question they have said like you have to choose 2 index more. So if we consider this example, let's say k equals to 1 if I am choosing, so I'll be comparing the first element, which is 9, right? So if you see 9 is greater than k, right? K is 1 here, so 9 was supposed to be belong here, but since it is greater than k, so you need to shift that 9 to the next position, which means I'll just insert a frequency. Basically the frequency vector will hold like at this position how many elements has been placed. Initially it will be all 0, we don't have any elements, okay. Now since I'm moving 9 to the right hand side, so its frequency will be 1. Now go to k, second element. Now here if you see 1 is equals to k, okay, which means the operation that we have chosen for k equals to 1 is going to be failed, and it's not a valid integer. So let's go to the next integer, which is k is equals to 2. 2 will also, it is going to fail because fourth element is same. So let me choose k is equal to 3. So we have 9172 and k is equal to 3 we have chosen, and we have a frequency vector 0 1 2 3 4 5, right? Now 9, if you see, it is at index 1, this is index 2, this is 3, and this is 4. This is index of the vector. Now 9, since it is greater than 3, it has to move to the right hand side. So 9, it is index 1, I plus 1 is 2, it is moving here. 1, if you see, it is lesser than 3, so it will be moving backward. I will be moving here. So basically it's like 9 is placed here, 3 is placed here, okay. Now 7, if you see, if it is greater than 3, so it will move to the next position, which is here. So it's like 7 is placed here. Now if you see the last element, which is 2, since it is lesser than 3, it has to be moved backward, okay. So it's like we have placed here, and if you see, we have placed here. It's a valid arrangement. So in this case we have to print yes. And if you see the frequency of these elements, index from 1 to 4, all as one element, and all as one element meaning they have been placed when k chosen is 3. So here answer will be yes for this case. For this case answer is yes, right? As you can see, it is yes. And yeah, they have chosen k is equal to 5. For k is equal to 5 also it is going to work, and for k is equal to 3 also it is going to work. So since we know like for multiple k it is going to work, so we need to fix search for the k. So since the element wi, it belongs from 1 to 10 power 9, so if we are fixing the k from 1 to 10 power 9, then we will definitely get TLE. So now the question comes, how do we choose optimally k, right? The hint to the problem is, since n is 100, we have weights till 100 only, right? We have weights till 100, so we can choose k values among these 100 only, meaning since w1 has some value, right, weight, the element present at index 1 has some value, so I'll make sure my k is, I'll make sure it has two values. One value is w1 minus 1, the other value is w1 plus 1. And why I'm not using k is equal to w? Because in the question they have said if the element that you're choosing is equals to the weight of the any element, so that operation fails. So that's the reason I'll not be choosing. So I have two choices now, w minus 1 and w plus 1 I'll be choosing. So once you have chosen these two, so at max how many elements you will be having in order to satisfy k? At max you will be having 200, because since the maximum size of the array is 100, so for each weights you will be choosing w1 minus 1, wi minus 1 you will be choosing, in general if you take wi and wi plus 1, so at max you will be having 200 elements. Okay, and now for these 200 elements you can definitely do a brute force solution. So how you are going to do now? Now what you are going to do is you are going to choose weights. Let me call weight, and in a vector let me call w, and the vector is weight, right? So each value I'm taking, now I'll be taking k1, basically one time k as w minus 1, the other time I'll be choosing it as w plus 1. Okay, now the logic inside how we have to do is, we have to basically check in from I 0 to n minus 1, we'll be checking if this weight of I if this weight of I, if it is equals to k, which means our operation has failed, so we'll have some boolean variable saying it's not a valid one, so validity I'll be making it as false, and then I'll break it out, right? Now the other thing that I'll be doing is, I'll be basically again checking if this weight of I is lesser than k, so I'll maintain one for every k, I'll be maintaining one frequency vector, and its size will be n plus 2. Why n plus 2? Because let's say when your I is equals to 0 and your weight of when I is equals to 1, basically the first element, and the weight of first element is lesser than k, so in that case we'll have to go I minus 1. So yeah, like we have total of n elements, so one previous you're moving, so and in case of the last element, weight of n, if it is greater than k, you will have to move to the right element. So that's the reason to n plus 2 will be taking, and initially it will be all 0. So what I'll do is, frequency of I minus 1 will be increased, which means the weight of I element whatever we have, it is placed to the left hand side. Else if we'll be checking weight of I, if it is greater than k, which means we have to place that element to the right hand side, right? Once we have done these things, we have got the frequency. Now in the frequency vector I from 1 to n, basically we will be checking if that frequency of I is not equals to 1, which means either the frequency will be 0 or it will have more than one value, which means frequency 0 meaning in that particular you have a weight vector, right? So frequency 0 meaning at this position we, after rearranging, after choosing k and you're doing a rearrangement movement, so you don't have any element here, but in the question they have said every element sorry, every position has to be a single element. Basically in the vector, all the position has to have a element. That's the reason. And if the let's say now it is like 2, this place can have 3 values, 0 1 2. 0 meaning we don't have any element, 1 meaning we have one element, 2 meaning we have two elements. If there are two elements, so again that is not a valid arrangement according to the position. So definitely all the frequencies should have a 1, which means we have, after choosing k, we have arranged the weight vector and it's a valid one. So we have to check if frequency is not valid, not equals to 1, which means again validity is going to be false. Break. Don't worry, when I'm coding you'll be definitely getting like how I'm solving. Once we have got all this check, now we have to check if it is a valid one, so we have to print yes and then return. If it is not, then I'll be choosing the next key. Basically from all the 200 combinations I'll be checking. Basically 2 into n, in general it will be 2 into n, based on n value we are choosing 2n keys. And at the end, let's say at the end all the keys are invalid, so when you're coming out of the all for loops, so you have to output no, which means you have not got any element. So the main thing of this problem is basically shifting the weights, right? You had anything like 1 5 7 3, something like that. So basically you had to choose element integer k you have to find, and you have to make sure the movement you are doing, the movement operations are basically, if weight is equals to k, then it is a failed operation. If weight is less than k, then it's a left operation. And if weight of I is greater than k, which is you have to move it to the right hand side. And the reason why I was omitting frequency vector, in order to make sure we have a unique element there. So basically when you are moving the element to the left hand side or to the right hand side, we will denote the one element is placed there. So yeah, which makes sense. So let's try to code it up. So what all we have a test case. So test case, I'm dealing it here. For every test case I'm calling a solve function, and for every test case we have integer n, and we have a weight vector, right? So I'll be taking all the weights. So I've taken all the weights. Now we have to do the validity checks. So one by one I'll be taking the weights, right? I'll be choosing k, which is initially w minus 1, and since I'll be choosing w minus 1 and w plus 1, for that let me choose a for loop. Let me take count, then basically what I'm doing is here k plus equals to 2, which means this will make sure I'm doing it for w minus 1 and then w plus 1, okay? And count this for loop will be executed only 2 times, since count is defined as 2. Now yeah, we'll define a vector frequency whose size will be n plus 2. Now one thing I'll correct here. I will not be taking in a 0 index space. I'll be taking in a 1 index space, right? This weight. Okay. It will be easy to in order to compare. That's the reason. So what we're checking, if weight of I is equals to k, which means it's not a valid, so valid will be false, then we'll break out of the loop. And before that we need to define one boolean variable valid, and initially it is set to be true. Okay. Else if we'll be checking weight of 5 if it is less than k, which means that element we need to place one position backward, left side. So the frequency of I minus 1 is going to be increased, which means at I minus 1 we have placed this present W of I element. Else definitely it is going to be weight of I greater than k. So in that case you have to place to the right hand side one position. Okay. Now before checking the frequencies, first we need to check if it is valid or not. This validity is coming from this one, right? In case weight of any element is equals to k, so it is not a valid, so we don't need to check frequency, because that's not a valid case. In the question they've said if weight of I is equal to k, the entire movement whatever we're doing, movement processing, it fails. Okay, so it's not a valid one. Since in this for loop this is not executed, which means it's a valid one, and if it is valid, then we need to check the frequencies. Now when you're checking frequency, if frequency of I not equals to 1, it means at that position we don't have a unique element, so in that case also it is not a valid. We need to break. Now we have to check if it is a valid case, like weight of I now equals to k, also the frequency of all the positions is 1, which means at all positions we have a unique elements, so it is a valid case. So if it is valid, then we need to print yes, and basically return. We don't need to check the other case. If the first case is not valid, k w minus 1, then we'll be checking for w plus 1, and we are doing it for all the weights, right? And if you are coming out of this for loop, which means you have not encountered this valid case, so any k whatever we have, it is not a valid one, right? So in that case we need to output no. Let's try to run it. Yeah, sample test is passing. Let's try to submit. I think we will not be able to submit right now because the system testing is going on, but yeah, this code will be accepted. This is the one that I had coded in the contest. So it's a easy problem only. Basically you had to you have to boil down the k values, since k had a lot of choices. So by doing trial and error, and by doing like what will be the k possible values, so you had to figure it out. That's it. So once you figure it out the k value, so definitely you will be able to solve the problem. So yeah, this was it, and let's try to analyze the time complexity. Time complexity, it is going to be, this is O of n, and inside this is 2 times, and this is O of n, so it is going to be 2 times of n square. And space complexity, it is going to be O of n, because we are using a frequency vector. So yeah, that's it. Thank you guys.